Hi everyone, my name is Amber Narcisse, and today I will be talking about the effect of milk consumption on longevity. Milk and dairy products are nutritious food sources that provide essential vitamins and minerals for our health. However, no randomized controlled trial has assessed the effect of milk on lifespan. There are studies that discuss milk intake on cardiovascular diseases and diabetes, but there are no Mandelain randomization studies that assess the effect of milk intake on lifespan. So, our question for this study is: does milk and other dairy products expand human longevity? In order to answer this question, I have conducted a two sample instrumental variable analysis to obtain causal estimates for a genetic variant associated with lactase persistence and longevity based on parental attained age by using an analytic platform called MR-Base. MR-Base is a platform that contains data from existing genome wide association studies. Lactose tolerance is exceptionally widespread in northern European countries and found in individuals with heritable trait known as lactase persistence. RS4998235 was the genetic variant associated with lactase persistence, which is the ability to digest lactose. RS4988235 is often used as a genetic predictor for dairy intake. My exposure milk intake was based off a meta-analysis of 5 studies accounting for milk intake as it relates to RS4988235 and was used to determine the estimation of the average effect size. After much review, I assumed that the study participants consumed at least 1 8-ounce glass of milk per day. Biological offsprings of longer-lived parents inherit a combination of parental genetic variants and tend to remain healthier and live longer than offsprings of shorter-lived parents, which is why combined parental attained age was obtained by previous genome-wide association studies and was used as an outcome for this study. Both my exposure and outcome were based on people of European descent. The meta analysis accounting for milk intake provided a sample of 102,729 for combined parental attained age, 389,166 UK Biobank participants provided data on their parents' current ages or parents' ages at death. For my results, by using the Watts estimates, genetically predicted milk intake based on RS4988235 was not strongly associated with combined parental attained age. A series of conversion equations was used to determine the years of life loss, which resulted in less than a year loss of life, 0.095. This suggests that daily milk intake of at least 1 cup per day does not significantly influence human longevity. In this study, I extended a previously published Mendelian study of milk intake by examining the association of milk consumption with human lifespan. Consistent with the findings for specific diseases and risk factors previously found, milk intake was unrelated to longevity. However, there are some limitations in the study that should be considered, such as the lack of diversity or different ethnic background. The participants were mostly of European descent. Also, different methods of data collection was used, such as 24-hour dietary recalls, food records, questionnaires. Also, there was no separations of the type of milk or other dairy products used, such as yogurt or full full fat milk or 2% milk. It was also difficult to analyze by age or sex, which wasn't specified. And it was also open to non paternity events, such as someone may report their father's age and not know that that's not their biological parent. In addition to these limitations, the study has a number of strengths. First, the large sample size. Second, genetic variants are predisposed at conception, which prevents reverse causation. Third, we use a longevity study for the outcome, which largely, sorry, excuse me, which largely obviates from the problem selection bias arising from only selecting survivors of the genetic makeup. Genetic variants are also subject to little measurement and error, and the data was vast and publicly available. Reasoning for this finding, there may be other possible explanations for this finding, but one has been studied. According to research done by Tucker, adults who drink full fat or 2% milk have significantly short telomeres than adults who drink non-fat or 1% milk. Telomeres have been deemed as a universal biological clock that shortens in parallel with aging in cells. Shorter telomeres have also been linked to multiple age related diseases such as heart failure. Therefore, depending on the type of milk product, consumption of it could have resulted in this finding. In conclusion, this finding has important implications for dietary guidelines and food policies. Milk and dairy products have been deemed essential given the nutritional benefits, but it does not seem to affect overall lifespan, and yet is still recommended in the US dietary guidelines. Future studies involving other populations as well as other dairy products can be used to further influence dietary guidelines and policies. Thank you for listening to my presentation.